Be sure to like the video and subscribe. Uh, in this video I will be solving paper 5 planning analysis and evaluation 970152 Feb March 2025. Let's start. Brass is an alloy of copper and zinc. An experiment is completed to find the percentage by mass of copper in a sample of brass. In the experiment, the sample of brass is reacted with an excess of concentrated nitric acid. Brass is reacted with concentrated nitric acid. This forms a copper ion. The amount of copper ion formed is determined by titration. A student uses the following method: weigh a glass beaker and record the mass. Step 2. Add approximately 1 gram of powdered brass to the beaker and record the mass of the beaker and brass. Step 3. Transfer the brass into a conical flask A which contains excess concentrated nitric acid. Re-weigh the glass beaker and record the mass. Add sodium carbonate dropwise to flask A in which nitric acid and flask A until a precipitate copper 2 carbonate appears. Then add dilute ethanoic acid dropwise until the precipitate is fully dissolved. Transfer the content of flask A to 100 cm cube of volumetric flask and make up to the mark with the distilled water. This is solution B. Transfer 10 cm cube of solution B into conical flask C. Add 10 cm cube and excess of potassium iodide to flask C. Titrate the content of flask C against 0.0600 mole per dm cube sodium thiosulfate aqueous using starch solution as an indicator. Repeat 7 to 9 until concordant results are obtained. Both copper and zinc in brass react with concentrated nitric acid in step 3. Zinc react with nitric acid to form zinc nitrate, nitrogen dioxide and water, while copper react with nitric acid to form copper nitrate, nitrogen dioxide and water. Suggest why step 3 in the experiment should be complete in the fume cupboard, as nitrogen dioxide is toxic gas. So that's why reaction is should be completed in fume cupboard. Explain why the glass beaker is reweighed in step 4. Reweighed in step 4 to be able to determine the exact mass of brass powder that has been transferred. Name a suitable piece of apparatus to transfer the 10 cm cube of solution B in step 7. Volumetric pipette. Identify the substance used to rinse the burette before step 9 is done for the first time. Sodium thiosulfate aqueous. In step 9, 0.0600 mole per dm cube sodium thiosulfate is used. This solution is prepared from 0.200 mole per dm cube sodium thiosulfate before the experiment. Describe how to make 100 cm cube standard solution of 0.0600 mole per dm cube from the 0.200 mole per dm cube solution. Give the name and capacity of any apparatus you would choose. So C1 V1 is equal to C2. To find out the volume of thiosulfate is used 0.200 V1 is equal to 100 into concentration is 0.0600 into 100. So V1 is equal to 0.0600 into 100 divided by 0.200. So volume needed is 30 centimeter cube. So 30 centimeter cube of concentrated sodium thiosulfate is taken in 100 centimeter cube volumetric flask with the help of 50 centimeter cube burette and fill the flask with distilled water up till the mark, up to the mark. Stopper the flask and shake the solution. Mass of glass beaker is 25.55. Mass of glass beaker containing powder brass 26.65. Mass of glass beaker after transferring brass of conical flask A gram is 25.65. Determine the mass of powdered brass added to conical flask A. So this is 1 gram. The volume measured in each of the titrations are shown in the table. This is rough titration, so subtracting from the initial from the final, 20.80, this is 20.30, this is 20.55, this is 20.40. Calculate a suitable mean titer to use in the calculation. So this is 20 point and we select these two values, 20.40 divided by 2. So the mean titer is 20.35. Calculate the percentage error in the titer in the titration 3. We know the accuracy of the titration burette is 0.05. So we use reading 2 times initial and final multiplied by 2, and titration 3 is 20.40 into 100. So the percentage error is 0.49. In step 8, copper 2 ions react with iodide ion. The ionic equation for the reaction is shown. Reaction 3 is copper 2 ion iodide to form copper iodide, and this is reaction 4. And using second sample of brass, another student determined the mean titer to be 17.35. of 0.0600 mole per dm cube sodium thiosulfate. Calculate the amount in mole of sodium thiosulfate in the student's mean titer. So mole is equal to 0.06 into 17.35 concentration into volume divided by 1000. The answer is 1.04 into 10 raised to 2 minus 3. Use the equation for reaction 4 and your answer H1 to determine the amount in mole of iodine that reacted. 1 is to 2 ratio, and 1.04 into the mole of sodium thiosulfate is 1.04 into 10 raised by 2 minus 3. So the mole of amount of iodine 5.21 into 10 raised by 2 minus 4. Use the equation for reaction 3 and your answer to H2 to determine the amount in mole of copper 2 ions in 10 centimeter cube of their solution B. Solution B containing sodium thiosulfate and copper 2, and we have 2 ratio 2. So the mole of amount is 1.04 into 10 raised by 2 minus 3. Calculate the mass of copper present in second sample of powdered brass. Mass is equal to mole into AR. 1.04 into 10 raised by 2 minus 3 into 63.5. So this is 0.661. The mass of the second sample of powdered brass was 1.05. Calculate the percentage mass of copper in the second sample of powdered brass. Give your answer to 3 significant figures. Percentage is equal to 0.661 divided by 1.05 into 100. This is 63. This is 62.95 and this is 63.0. This is percentage by mass of copper is 63.0. Question number 2. Ester X has the formula CH3COOR. R is an alkyl group with the general formula CnH2n plus 1. Ester X undergoes alkaline hydrolysis with aqueous potassium hydroxide. Alkaline hydrolysis. The resulting mixture is acidified with dilute hydrochloric acid. The organic products of the hydrolysis after acidification are ethanoic acid and an alcohol. Once the identity of alcohol is found, the structure of ester X can then be determined. Student uses the following step. Equal molar quantities of ester X and KOH are placed in the round bottom flask. Few drops of suitable indicator are added to show whether a reaction has occurred. A substance is added to promote smooth boiling. The reaction mixture is set up for reflux and heated for 30 minutes. After 30 minutes, the reaction mixture in the round bottom flask is acidified by adding HCl dropwise. Thin layer chromatography is carried out on the reaction mixture. Complete the diagram in figure 2.1 to show the apparatus used for reflux in step 4. Label the diagram. this is reflux condenser. Liebeck condenser from water out, water in. It suggests the type of substance added to promote smooth boiling. Anti-bumping granule. As the reaction proceeds in step 4, the indicator changes color. The table 2.1 shows the color of three different indicators of pH 1 and pH 14 and the pH range over which the indicator changed color. Thymolophthalene 10.5, 3 to 4.5, and bromo cerasol green yellow 4 to 5.5. At 5.5 yellow, and this is blue. Indicator we can use because potassium hydroxide is used, so thymolophthalene, because it changes color at 10.5. As potassium hydroxide has high pH, so as it is used, the pH decreases and indicator will change color. The other indicator will not change color, so thymolophthalene is used. In step 6, a small sample of the reaction mixture is analyzed along with the sample of ester X and ethanoic acid. This is reaction mixture. State what feature of chromatogram shows that the hydrolysis is incomplete. There is a spot in the reaction mixture. Chromatogram which matches the ester chromatogram. Suggest an experimental process that could be used to extract the alcohol from the reaction mixture. Fractional distillation. Because both have different boiling point and miscible. Shows an infrared spectrum of the ROH extracted in D. Use table 2.2 explain how the infrared spectrum. Figure 2 shows that the ROH extracted does not contain any ester. So it does not contain any ester because the peak at 1710 to 1750 is missing, which is of C double bond O of ester. So at this point peak is missing for ester C double bond O. So that's why as peak is missing at 1710 to 1750. Figure shows the proton H and MR spectrum of compound alcohol. This peak is singlet peak, this is multiplet, so it means this is doublet. It means the alcohol should be if alcohol is like this, CH3 CH2 CH2 OH, so this is CH2 and CH3, so it is not OH peak is, this is for OH peak, and this is 6 pH, it means it is doublet, so it means CH, and this carbon has 6 hydrogen atom. This is O and H. This OH is the one hydrogen responsible for one hydrogen, so this is for OH peak, and this is 1H multiplet peak, and this is one hydrogen, mean this hydrogen is responsible to have a multiplet peak. This is 3 hydrogen and this is 3 hydrogen, it means this is 6 hydrogen. So 6 hydrogen responsible this doublet peak, and this CH responsible 1 hydrogen responsible multiplet peak. So it means at 2.1 this is 1.2, this is 2.1, and this is 4.0. So at 2.1 peak is singlet, and at 4 peak is multiplet. So this is singlet peak is for OH, and multiplet peak is for CHO. This is responsible, CH responsible for multiplet peak because 3 hydrogen on this side, 3 hydrogen on this side. So this hydrogen responsible for multiplet peak. So ROH is the propane 2-ol. Draw the displayed formula for the ester X. If the acid is ethanoic acid, so the structure of is like this. Draw the displayed formula for the So this is displayed formula of X. Ester X will undergo hydrolysis with water in the presence of sulfuric acid under flux. Using a similar procedure, suggest why none of the indicators would change color in this experiment, as it does not affect acid is the catalyst in the hydrolysis of an ester, and so is not used up, is not used up. So the pH does not change. The pH does not change. So this is all about the hope you understand this paper. If you understand, like, please share, like, and subscribe the channel.